Dear students and participants of the course on railway engineering, I welcome you all back to the lectures. We are going to discuss about the ballast today, which is one of the component of the railway track. In the previous lecture, we talked about the sleepers, the various types of sleepers which can be wooden, steel trough, cast iron and concrete sleepers. And then we emphasized that the concrete sleepers are the one which has been used nowadays. But yes, there are certain locations where the concrete sleepers are prohibited, and that's where the composite sleeper use can also be there. In this discussion, we are going to start with the functions which the ballast provides to a track. What are the requirements with respect to the ballast if that has to be used on a track? What should be the depth of the cushion? What are the various specifications related to it? What type of the sampling conditions can be there? And then finally, what are the types of ballast and few other aspects. Let us start with the ballast. Now, what is ballast? As we have seen in the case of various tracks, we have a formation level, and at the top of that formation level, we are going to provide a sort of an embankment which is basically a ballast cushion. And on this ballast cushion, we are providing the sleeper. So, this is the ballast cushion and there is a packing on the sides, and then at the top of this sleeper we are providing a rail through which the loads are going to be transferred. So, here what we are talking about is this particular portion. So, it is a layer of broken stones, gravel, muram or any other gritty material which can be placed and packed below as well as around the sleepers for the distribution of load from the sleepers to the formation. So, the load comes here, then it is getting transferred to the area here, and then finally it is coming to the formation level in this form. And the same thing is going to happen on the other side when the load comes this side also. And this is being distributed from the sleepers to the formation and for providing drainage as well as giving longitudinal and lateral stability to the track. So, if there is a possibility of water which comes here, then that water should not go into the upper layers as well as it should drain out to the other side. So, that means the gradation which we are going to use is such that allows the water to move from one side to the other side, so that it does not get pounded there and starts creating a problem to the mineral composition of the ballast or the type of ballast which has been used there. So, what are the functions? Now, we have understood the things. So, on the basis of that, these functions can be very easily created. Very first thing is it provides a level and hard bed for the sleepers, because the sleepers are being rested at the top of it. Then on the basis of packing, it keeps the sleepers in position. So, there is some material which has been placed on the sides also. So, there is a material which is placed here, there is a material which is placed here. So, it will keep the sleeper in position. It transfers and distributes the load to a wider area, and that wider area is related to the final formation level. Then it provides the elasticity and resilience to the track. The loads can come, there can be readjustment of the particles, and if the loads goes, then it comes back or it remains in that position. So, some resilience has to be there. It should not be a very rigid structure, so that as soon as the loads increases, it goes into a distressed condition. So, that is also an important aspect. So, it does that. It provides longitudinal and lateral stability in terms of the way it packs the sleeper, and the top of sleeper you have the rail. So, this whole of the composite system we are talking, and where we are looking at this stability aspect. It provides effective drainage, it maintains the levels and the alignment of the track. These are the various functions. So, on the basis of that, what should be the requirement? The very first thing is whatever the aggregates which have been used as a part of the ballast, iron gritty material which has been used as that ballast, it should be tough, and it should be able to resist the wear. That means when you are talking about tough, one thing is the shocks. So, if any shocks have been created, the ballast should be able to withstand or absorb those shocks. And when you talk about the wear, we are talking about the abrasion condition. There is a particle and this is another particle, and because of the load comes on one, so there is a relative movement and the surfaces are getting rubbed. It should not get transformed into powder. So, that resistance has to be there. They should be hard enough not to get crushed under the moving loads. So, at the top of the rail, the wheels are moving, the load is shifting. So, you have the rail being provided like this, and then the load is shifting continuously on the movement of the wheels. So, whatever the ballast is being provided here, it should not get crushed because of the loads which comes here. That is another property. It should be cubical in shape with sharp edges, and if this has a sharp edges, it allows for interlocking and thus making a composite mass at the bottom. It should be non-porous and non-water absorbent. If it is water absorbent, then there will be a problem in terms of the quality of that material in a longer duration. It should be able to resist attrition. So, there can be another problem here. So, with respect to the sleepers which have been provided at the top here, so it is also going to have a rubbing action with respect to that. So, there are two things which are happening, the rubbing because of the same material and rubbing between the two different materials. So, that is where we have to talk about abrasions and attritions. It should be durable to bear environmental effects. When we say environmental effects, that may be mainly in terms of the moisture and the availability of moisture for a continuous sustainable for a continuous time period, then that is going to create a problem here. Good drainage we have already talked about, and then whatever are the requirements here, it should not happen that because of looking at that requirements, we go for such a material which is very costly. Now, here we are talking about the tracks which are running in something like 68,000 of kilometers. That is what we discussed in the very first lecture, and it is going to increase in the coming years. So, this cheap and economical is another aspect which also needs to be looked at in terms of a requirement of a use of a material as a ballast. Now, let us look at the cushion which is provided below the sleepers. So, when you are talking about that cushion, so this cushion is coming here. So, this one is the cushion which we are talking. A cross slope of 1 in 30 is provided. So, that means with respect to the center line, we are going at a slope. So, this is 1 in 30. And older constructions, there may be a possibility the slope has been provided as 1 in 40. So, if it is the track which is simply being renewed and not everything is being taken out, then we maintain that 1 in 40, but if we are going a complete renewal, then we go for a 1 in 30. Now, minimum formation width we have discussed previously when we talked about the permanent way and the tracks for single line and a double line systems. For a single line systems, it is 7850 mm, which needs to be ensured. So, here this you have to be careful that this is for single line track, though we have discussed this previously. So, the different values have been given. So, what you can understand here is that this is a value A being provided, there is a value B here, there is a value C, this is D, this is E, then there is a value F here and the value H is provided here and the gauge is provided on this side. So, when we are looking at these different aspects, these values are being defined here in the table. We are talking about the broad gauge, we are using the concrete sleeper. So, for that condition there are three possibilities of the depth of the cushion. It can be 250, 300 or 350. There are changes which are coming in C and E element. The C and E element, C element is here. So, this is changing element, and with respect to that obviously the E element is also going to change. Now, this C is going to change based on the outer curve conditions where this width is increased. As you can see here, it is being said that it is instead of 350, this is going to be 500. So, there is a direct change of 150, and accordingly the D and E, they are going to be different. And finally, the height, which is the total height which we are talking, because there is a cushion below, but then in this area there is some more packing which is being done using the ballast. So, the height is going up to that, and that is varying from 646 to 751 mm. And based on that, for a straight track and a curved track, the quantities have been calculated in meter cube. Now, when we say that C value is changing, that is what we have talked about. So, on an ordinary fish plated track to be increased to on the outside of the curve to 400 mm if curve radius is more than 600 meters. In the case of SWT, it is to be increased to 400 mm on outside of all curves flatter than 875 meter radius, and to 450 mm if the radius is more than 875 meters. In the case of turnouts in passenger yards, it is to be increased to 550 mm. So, the C values, they are changing based on the location, and that is another important aspect which needs to be taken care of. Okay, so here this is a standard ballast profile which has been given for a broad gauge, but not for a LWR or CWR, that is a bit different. Here again the depth of the cushion, and along with depth on the straight and curves with a flatter than 600 meter radius and more than 600 meter radius, the quantities have been calculated, and these changes are related with respect to the changes in the C values or the CES value which is provided on the outer side. This is another one where we are talking about a ballasted profile for LWR track. The values of various elements, as I said, are being given. Here we have talked in the case of permanent ways also that this formation width F being provided at the bottom, it has to be minimum 13160 mm. So, that value will be there. The one change which will be there is in terms of J, that is the distance between the two tracks, and this is taken as center to center distance, and the values are 5300 mm, and these tracks which we are talking, they are related with LWR conditions. That means the long welded rails have been used here. Again, for broad gauge and for a concrete sleeper which has been used at the top, the values are being specified. There are certain values which are same, only few values are changing in this particular case. So, how to find out the minimum depth of the cushion? The minimum depth of the cushion is nothing but it is half of center to center sleeper spacing minus width of the sleeper. Now, how that is coming? As you can see at the bottom, so there is a center to center spacing. The loads are coming on this sleeper. So, there is a load P which will come here through the rail, and through the rail seat it is going to be dispersed to a wider area and will come on the sleeper base, and whatever is the base of the sleeper is through that it is going to be transferred to the ballast cushion at the bottom. And considering that this distribution is at an angle of 45 degree, what we get is, so if this is the depth of the ballast cushion and this is 45 degree, then what is the value here? So, this is also D and this is also D here, and this is the width of the sleeper. And similarly, on the other side also the same thing is going to happen. So, considering these, then this formula has been found out that if we have a center to center spacing, from center to center spacing, if we reduce the width of the sleeper, because half is coming here and half is coming here. So, this is if width of the sleeper is Ws, so this is Ws by 2. So, Ws by 2 and Ws by 2 has been taken together. So, that goes out. So, what you are left is this particular distance, and with respect to this distance now we are calculating that what should be the minimum depth. So, in that sense, if you are looking here, so there is a width of the sleeper being defined by small w, there is a distance between the sleepers which is 2 dB, sleeper spacing center to center is S, and dB is nothing but it's a depth of the cushion. It means whatever is the clear distance between these two sleepers is there, that is uh, basically twice of the depth of the cushion at the bottom. So, from there this is being found out. So, let us look at one of the numerical here. What it says, there is a rail track which is being laid with 13-meter long rails. There are monoblock concrete sleepers of bottom width 250 mm and uniform center to center sleeper spacing of 650 mm. So, this is S, this one is W, this is the length of the rail L. Calculate the depth of the ballast cushion if the distance of center of first sleeper from rail end is 390 mm. That means it says that if you have a rail system being provided, so there is a rail here and this is the end. So, there is going to be one sleeper here and then the spacings of the other sleepers will be different, as we have discussed previously. This was A, this was B, this was C as shown there for different locations. So, that value 1 is being given to you, that the first sleeper is at a distance of 390 meters from the rail end. So, this is from here, it is 390. So, minimum width here is 0.5 times of the center to center sleeper spacing minus the width of the sleeper, and if we go with that value, so center to center spacing is being given as 650 and width of the sleeper is being given as 250. So, it is 650 minus 250, so that is 400 and half of that, so divided by 2 means it is 200 mm is what is to be provided. Then another example is a rail track is laid using 13-meter long rail and a sleeper density of m plus 6. Calculate the depth of the ballast cushion if the sleeper width is 25.4 centimeters and the distance of first sleeper from the rail end is 280 mm. So, first of all we have to look at the sleeper conditions. The number of sleepers which have been given per rail length is m plus 6 and the length of the rail is 13 meters. So, using that, m is 13 and 6 is a factor which is already being given, what we get is 19. So, there are 19 sleepers which have been provided. Now, the width of the sleeper is being given to us. So, we need to find out the center to center sleeper spacing. The center to center sleeper spacing is what? It is 13-meter long. So, it is 1300 centimeters. Then there is a distance of the sleeper from the rail end, that is 280 mm. So, 28 centimeters goes from one side on this and from the other side of that rail end, and then there is a width of the sleeper which is 25.4 and that is being divided by the number of spacings between the 19 sleepers will be minus 1, that is 18. So, 19 minus 1. So, what we get is 67.7 centimeters as the center to center spacing between the sleepers. So, the minimum width in that sense comes out to be 0.5 times of the formula is the same one. If you put the values there, what you get is 211.5 mm as the ballast cushion. Now, here some values have been given at the rail seat for the broad gauge track renewal with the through sleepers renewals 300 is what is to be provided on all routes, and where possible 350 shall be provided. On doubling gauge conversion, new line construction 350 mm, on the loop lines 250 mm. So, these are the minimum values which are already specified. At sidings where private or other type of sidings, for a permissible speed of up to 50 kilometers per hour, then it is 300 mm. For permissible speed more than 50, it is 350 mm. So, as the speed increases, as the loads increases from the top, that means we need to increase the thickness of the ballast cushion. Now, for mechanized maintenance under the rail seat of PSC sleepers, it should not be less than 150 mm at any point of a time. So, this is another requirement being laid out in the guidelines, and the guidelines which I am talking here is the Indian Railways Permanent Way Manual of 2020. Then for tracks with speeds beyond 110 kilometers per hour on broad gauge for passenger trains, If the speed is between 110 and 130 kilometer per hour, then it is 300 mm. If the speed is more than that and goes up to 160 kilometers per hour, then it is 350 mm. So, this is the what value which is to be provided. Now, special attention should be given at locations such as bridges, level crossings, tunnel approaches, ensuring the full ballast section for 6 rail lengths on either side. So, if your tunnel starts here, so this is the area from where the tunnel starts and your rail is coming on this side. So, what it says is for 6 rail lengths on this side. So, this is the 6 rail lengths. Up to that, it has to be maintained in that form. Increase in the ballast cushions shall be carried out during complete renewal of track or sleepers, or likewise any other such overall renewal is there. So, previously it might have happened that you have provided 200 or 250, but now in general we are going for 300 or 350. So, that change in the thickness has to be done at the time of a renewal. Now, let us come to the ballast specifications. We talked about that it should be hard, it should be non-abrading, it should have good strengths, it should be durable, it should be angular so that it has a good interlocking with the other particles, it should free from the organic impurities. It all depends what type of aggregates you are using. So, there is a possibility of organic impurities. We have to go for a check and we have to take out those aggregates or types. Inorganic residues, if they are there, then that also has to be looked at, or there is a weathered portion of the parent rock, then they should not be used. They should be cubical in shape but not flaky. When we say flaky, it means we are talking about something like this. If this is a case, then this is width, this is a thickness, so it is okay. But if say I talk about a thing which is having very less of the thickness like this, then this is a elongated flaky conditions. Then machine crushed for all broad gauge lines and running lines except for E routes, including E special routes. These routes we have discussed previously. Preferably machine crushed for all other broad gauge lines. Hand broken can be used under exceptional conditions with the approval from the chief track engineer. Otherwise, mostly we are going for machine crushed things. Then some other properties, the abrasion value maximum 30%, and it can be relaxed up to 35%, but again the permissions needs to be taken for that. If we are talking about the impact value which is against the shocks, 20% maximum and relaxable up to 25%. That means the laboratory test has to be done so as to ascertain this. And it also said that they should not have a high water absorption characteristics. So, the limit has been given here 1% maximum, that is the water absorption which can be there. Size and gradations, retained on 65 mm square mm sieve only 5%, rest 95% should pass through it. Retained on 40 mm square mesh size, 40 to 60% is the range which is being given, and that too for a machine crushed only. So, this is a retention, it means 60 to 40% is passing in this case. And then the another sieve size is 20 mm. In this 20 mm, not less than 98% should be retained for machine crushed, and for hand crushed it shall not be less than 95%. So, these are the values which are there. It means you have to go for a sieve analysis to ascertain whether this material which is being given to you can be used or cannot be used. Then another thing is the retention of 65 mm square sieve, which we talked here. When we said retained on 65 mm square sieve is 5% maximum. So, with respect to that, what it says? It says that we have to see whether the ballast which has being received is oversized. Now, how to decide it is oversized? Ballast with more than 10% retention shall be rejected. We talked about 5% there. So, if it is more than 10%, reject that. If it is within 5 and 10%, then 5% reduction in the payment made for full stack which has been received. So, this is how as an engineer at a site you are going to take decisions. Similarly, when you talk about 40 mm, when we say 40 mm, we talked about the values as 40 to 60. That means maximum retained is 60. So, with respect to that, what it says, if the retention is more than 70%, ballast has to be rejected. So, that means it is giving again a leverage of 10% beyond 60. If the retention is between 60 excluding and 65 including, then 5% reduction in the contracted rates has to be done. If the retention is between 65% excluding and 75%, then 10% reduction in the contracted rates has to be done. But as soon as it is more than 70%, it has to be rejected. So, it says that we can go up to 70%, we can use that, but then the penalty has to be imposed. Again, these has been taken from IS RDSO GE 001 2023 guidelines. Now, in case of hand broken ballast, the ballast shall be well graded between 65 and 20 mm size. It should not happen that there are much material which is just either passing or retained on one particular sieve itself. So, we need to take care of that. Similarly, there is an undersize. We talked about the oversized. Now, undersized ballast can also be there. So, undersized ballast in terms of a 40 mm square mesh sieve, we said that 40% is the minimum value which has to be retained. So, if it is going here retention of 50 mm is less than 10%, then it has to be rejected. If the retention of 20 mm sieve is less than 98% for machine crushed and 95% of hand broken, then also this is going to be rejected, because these were the values which were there in terms of the acceptance criteria. Now, come to the measurement. There are two different ways in which the measurements can be done. One is a stack measurement, another can be a wagon measurement. The stack measurement means that you have the material, the material has been deposited at site in this type of a stacking conditions. How to do that? Height of a stack shall not be less than 1 meter except in hill areas where it can be 0.5 meter. So, this is one thing which is being decided. Then height of a stack shall not be more than 2 meters. So, there is a minimum and maximum being defined. So, 1 meter and 2 meter. Then the top width of a stack shall not be less than 1 meter and parallel to the ground. So, this top width shall not be less than 1 meter, and then this is parallel to the ground. Side slope of the stack shall not be flatter than 1.5:1. That means this has to be maintained as this. This is horizontal to vertical. And the cubical content shall not be less than 30 cubic meter in plain areas and 15 cubic meters in hilly areas. So, if this has been considered, then we will get the amount of quantity which we have got at any location. So, that is the way we have to do the stacking, and then stack measurement by itself will come. So, we just go and take the height, we take what is the width at the top, we take what are the slopes being provided, and that will give you an idea. In the case of wagon measurements means you get a wagon. So, wagons are coming like this, and up to one particular point they have been filled with the material. So, that is how we are talking here. So, ballast to be filled up to a white line which is painted inside the wagon. So, there is going to be a white line here all along the periphery of the wagon. Cubical content corresponding to white line should be painted outside wagon on both sides. So, it means on outside we are writing, if you are putting it up to this particular line, then so much of cubic meter material will be there in this wagon. Short pieces of flats, cut pieces of tie bars or otherwise with cubical contents punched shall be welded at the center of all the four sides as permanent reference. So, inside there is going to be this tie bar material which is being provided. So, it will be there. So, if you are talking about a wagon like this, so in that case, so here it is going to be provided in that form. So, a continuous one is going to be painted, and at that particular paint then tie bar is being fixed. Now, shrinkage allowance of up to 8% is permitted in the wagon, because when it is being transported from the quarry site to the location where it is to be transferred, along with the shocks and vibrations. So, due to shocks and vibrations there will be a problem, and that is why we need to take this allowance of 8%. Now, comes to the sampling of the ballast. is not to be done directly from wagon or dumped or stacked or inserted ballast in wagon or on ground. One sample from each side, one from top. Now, because you have done the stacking, it has been put on the ground, it has been in the wagon. So, there will be a segregation, and if it is a segregation, you take it out and you do the sieve analysis, then you will find that the results are not there, and whereas the material which has been transported was correct, it was good. So, that is where you have to take one sample from top after removing 150 to 200 of the outer layer, one each 0.3 to 0.5 cubic meter volume, and mixed to create a gross sample. So, that is how the sampling is to be done. Sampling frequency is first 100 cubic meter all test by Indian Railways. Size and gradation, one for each 100 cubic meter or part of it, that means less than that. We go for impact value, abrasion value, we go for water absorption, and these tests has to be conducted for every 2000 cubic meters. Now, let us come to the ballast type. There are different type of ballast which can be used as broken stones, which are mostly used on Indian Railways, procured from hard stones like granite, quartzite, hard trap, and these by name itself, this is a igneous rocks conditions. So, what happens is they have a better strength properties in terms of abrasion, in terms of impact, etc., and they are economical in long run because they have been able to bear the loads which are coming without breaking. Sand is another one which can be used, but the sand is used mainly for the PI or the cast iron pot sleepers, or in the low density areas, or with wooden sleepers or with ST sleepers also the sand can be used. But when the sand is being used, it shall be the coarse sand, and it causes excessive wear on the rail top and moving parts of the rolling stock. So, that is a problem. So, there will be a abrasion condition which will come up slowly, and you will find that there are defects on the top of the rail surface or on the sides of the rail surface, because the sand will get accumulated there, and when the wheel passes under that, it will work as a grinding action. So, this grinding action will create a problem. It can be blast furnace slag or cinders, but they are usually used in the yards and sidings. They are used as initial ballast in the new construction, and then finally, they have been converted into the broken stones. They are cheap and easily available, but they are corrosive, they are harmful for steel sleepers, and they are harmful for the fittings also. That is the reason mainly we go into the yards and sidings. Muram can be a possibility, but again this is the initial ballast. In the new constructions it can be used as, or it can also be used as a sub ballast, but then it will be replaced by a better material later. It is also used as a blanketing material on a black cotton soil. So, that means we are talking about the formation, and if the formation has a problem, then at the top of the formation we put the muram, and then only we will go for the cushion of the aggregate and rest of the construction. There are other possibilities also. It can be gravel, it can be river pebbles, it can be conker, it can be brick ballast, etc. Now, let us come to few specific things. The one is the packing. Packing is what? It is a compacted ballast cushion which is laid below the sleepers as per the gradation. So, as I said, this is the sleeper which is provided. So, there is a ballast here, but then there is a ballast on the sides also. So, on the sides it is this the ballast which is being provided at the bottom, it is a packing. Boxing, relatively loose ballast which is being placed on the sides. So, this is here, this is known as boxing. So, this is how the sleeper has been placed into the position. So, with this we close this lecture or our discussion. What we have discussed is, we talked about the ballast, we talked about what are the various functions it imparts to the track and what are the requirements on the basis of that. Then there was a discussion on the minimum depth of the ballast cushion which should be there. We also did some of the numericals based on this. Then the specifications of the ballast and the sampling were discussed, and finally the types of the ballast which can be used in the track was taken up. With this we close this lecture. Thank you, and we will meet in the next lecture.